So here we're going to learn how to find slope in a variety of different ways. So, first thing, if I have a equation in slope-intercept form, y equals mx plus b, then we know that the m is the slope and the b is the y-intercept. So if I give you the equation y equals 1/5 x minus 4, we know that the slope is what, Michael?
1/5x, or 1/5, 1/5.
1/5. It's not the x, it's just the 1/5. Okay? What happens if I give you an equation like this? 2y equals 3x plus 1. If it's not in slope-intercept form, what does that mean? What do I have to do? Anybody? I have to get y by itself. So in order to get rid of a number in front of a letter, obviously I divide by that letter. If I divide by 2, I have to divide everything by 2. That cancels, and now, of course, y equals 3/2 x plus 1/2. So, Angelica, what's the slope on for this function? All right. So, if I give you an equation, and it's in slope-intercept form, m is your slope. If I give you an equation that's not in slope-intercept form, you have to change it. So it is, right? All right, one done. So now let's go to a graph. So I have a coordinate plane. So this is another way to write a function. So let me go ahead and put, let me see, I'm going to put 1 point there and 1 point there. Okay, so I can graph that. Let's see how good I can connect them. Close. All right, so if I have a graph, I can find slope on the graph by doing my steps. Remember my rise over run. I have to know 2 points. So in this case, here's 1 point, which is actually my y-intercept, and here's another point. So now I create a slope triangle. Rise, run. Up, 1, 2, 3, 4. Over to the right, 3. So since slope is rise over run, I rose 4, I ran 3, and it was positive. So in this case, my slope is 4/3. Okay? We know the slope going up and to the right is positive. Opuesto. Okay? No, that's opposite. Positivo. All right, so if I do, let's say this one, here's a point, and there's a point, and I create this graph. First of all, what could you tell me about that slope? Any of you? What could you tell me? Well, yeah.
It's going down.
No. It's going the opposite direction, right? So if this one was positive, then this one is negative. If it's from multiple choice test, you could get rid of the positive one. I still do the slope triangle the same way. So, rise, run. Make sure your slope triangle has vertical lines and horizontal lines. Some kids like to go at an angle. So now I rose 3 and I ran 1, 2, 3, 4, 5, 6, 7, 8, but it was a negative 8. So my slope in this case, rise over run, was up 3 over negative 8, which we know in the end is negative 3/8. Okay? So, when we have a graph, we make slope using a slope triangle. Slope triangle. So, 2 ways to find slope. Now, we have a function table. We know that in a function table, I can also find slope. So, here's our function table with x our input or domain, and y our output or range. Important to remember that vocabulary. we know that a function has a pattern to it. So when I write my x inputs, let's have a pattern this time of, how about 0, 1, 2, that's easy. And over here, -3, -5, -7. We know that slope, again, is rise over run. We know that the rise is our y-axis, and our run is our x-axis. Basically, all we're doing when we have a function table and we find the rise and the run, we're just finding the distance between these 2 points and those 2 points. So if I go from -3 to -5, I'm actually going down 2, so that's -2, and then the same thing there. So in this case, my rise is -2. So I want you to remember that for the next one when we actually use the slope formula. We're just finding difference between these 2 x places and then our y places, then these 2 y coordinates. Now let's do the run. So the run, we again find the distance between them. So 0 to 1 is +1, and the same thing there. We want to do both so that we know it's a pattern. Now our run was +1, so at the end, -2 over 1 is -2. So our slope for this one is -2. Okay, now let's do a different one. Okay, so here's my function table. Here's my x input, my y output. So this time I'm going to do 0, -2, -4. Okay, over here I'm going to make this, I don't know, 1, 4, 7. So notice that my inputs aren't counting by 1. Doesn't matter. Slope is still rise over run, which is still the difference on my y-axis over the difference on my x-axis. So that's why we find the difference between these when we do our pattern. Okay, so we know the pattern here is +3. So our rise is +3 or just 3. Okay, so now we have to find our run, which is the difference between these coordinates. So Tyler, what's our run?
-2.
Right, I'm actually subtracting 2 each time, or -2. So now we have a +3 over a -2, which we know is just going to be -3 over 2. So that's our slope there. So remember, if I'm just adding by ones in the x column, our pattern of y's is our slope. But it's best to use rise over run, no matter what you're doing. Okay? Now, that's going to help us on our next thing, because now I'm going to give you 2 points, 6, 3, and -1, 5. I want you to find the slope between those 2 points. So here we have 2 points. Now, first thing is I can do this graphically. I could put it on a graph and use my slope triangle, right? Or I could do it algebraically, which is the slope formula. That's easier. Why should I make a graph and do slope triangle when it's one step to do the formula? Here's the formula. Slope equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All these base numbers mean is that I have to do it in order. So if I start with this y and subtract this y, I have to do the same order with my x's. So I like to just have you guys remember y minus y, x minus x. So do you remember back here on the function table? Isn't that what we did with our y's and x's? We found the difference between them. That's all you're doing here. It's just a formula now. All right. So make sure you use y's on top, rise, x's on the bottom, run. So I always go left to right. So I'm going to take this y and subtract that y. Then I'm going to take this x and subtract that x. Okay? Now, what am I going to do with the minus? Same change opposite, same change opposite. And what do I get? 3 plus -5 is -2. 6 plus 1 is 7. Can I simplify that? So your slope is negative 2/7. Up 2 and over to the left, 7. Easy, huh? Okay, let's do another one. All right, give me one set of ordered pairs, Michael.
5, or positive 5, 8.
Okay, and give me another one, Ariel. Make one of them negative.
Negative 2, 6.
Okay, so we're not going to do the graph because we know that's wasting time, so let's do our formula. So I'm going to write my formula, m equals y minus y, x minus x. All right, so I'm going to take this y and subtract that y. Easy. Then I'm going to take this x and subtract that x. So it's important that you put these in the right place. Since I'm subtracting, I got to do same change, opposite. Same change, opposite. So 8 plus negative 6 is 2. 5 plus 2 is 7. So your slope is 2/7. Up 2 and over to the right 7. So we now have 4 ways to find slope, and I'm going to add one for you. Here's a pattern or sequence of numbers. 2, 7, 12, 17, etc. This is a pattern. I could graph this, I can write an equation for it, I can make a function table for it, so that means I can find slope and y-intercept. Here's how we do it. This is the first term, second term, third term, fourth term. In other words, the first thing I have is 2, the second thing I have is 7, and so forth. That means that the term is my x input. It shows what place in my sequence I'm at. I have to have the term before I know the number in the term, right? Okay? That makes what's in the term my y output. So, if I want to find slope, I do the same thing as I did here. It's just instead of a table format, going up and down, it's going left to right. So, what's the difference between your y's? What's your pattern? Yep.
Plus 5.
Yeah, adding 5. So if we know slope is rise over run, and we know the number in the pattern is your y's, that means my rise is 5, okay? And my run, well, I'm just counting by ones, aren't I? So that would be 1 here, so my slope is 5 of this. Now, to end, let's actually write the equation for this. So you can tell me what how about the 80th one here? The nth term. I want to know the 80th number. You could keep counting by 5s until you get to that 80th one, but that's a long time, right? So I'm going to write an equation. Y equals mx plus b. You already know that it's y equals 5x. So we need to know the y-intercept, or where to begin. Well, if this was the first term, we had to start somewhere, right? Basically at nothing. So that nothing would be our 0 term. So I need to go backwards to here. So if I'm adding 5 going this direction, what would I do going back 1? Subtract 5. So if I was at 2 and I subtracted 5, what would this be when I started? Negative 3. That's your y-intercept. There's your equation. And now I want to know the 80th term. Didn't we say that the x's were the terms? So I'm going to substitute 80 in for x. 5 times 80 plus negative 3, 400 plus negative 3, 397. So if I were to continue counting by 5s, the 80th time I do it, I would be at 397. So it kind of tells the future. So in real life, there's businesses that want to predict the future, how many employees I need a year from now, 2 years. Okay, in medicine, How will that tumor grow? How tall will the baby be? So they use mathematics to do that. Excellent work. Good job, Michael and Tyler and Ariel and Angelica. Say goodbye.